thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, thank you for joining us for the Oxygen Concentrator Talk brought to you by the Oxygen Alliance. My name is Mayo Lungu and I'm very pleased to be hosting the call. I am joined by my colleague Linda Mishoni along with our usual technicians from OpenO2 and Sunrise. So in case this is your first time joining us and you are not aware, the Concentrator Talk Call is a virtual meeting that we host every Thursday from 2 to 3 p.m. Central African Time. And here we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So if you have any issues with your machines, you can always reach out to us and our technicians will do their best to help you out with the right solutions. So the calls are also recorded. So if you happen to have missed any of our calls, you can find them on our YouTube channel. So if you just search for Oxygen Alliance on YouTube, you'll be able to catch up with all the calls that we have had previously. During the call, we'll also be having a topic of interest. And for this topic of interest, we'll be continuing from where we stopped in our previous call. So we began talking about troubleshooting and fixing common problems in oxygen concentrators. So last week, Eunice presented the first part, and this week, Fatani is going to continue from where Eunice stopped. So we also have polls at the end of some of the questions, so please respond to them when they get launched. And in case you have any questions relating to any of the questions we'll be discussing, you're always free to ask those questions. All right, so now let's jump on to our questions for today. So our first question says, hello, a DeVille BIS 525 was brought to the workshop because it would periodically shut down when switched on in the ward. When I switched it on, it would run for a minute or so and then start vibrating. After that, the compressor stops. I have no idea what the problem is. How can I solve this? So I am going to ask Eunice to respond to this one.
Thank you very much, Maui, for the question. So a compressor in an oxygen concentrator is responsible for pulling atmospheric air into the concentrator and providing compressed air through the exhaust port. So there are several reasons a compressor could stop running. These include overheating or a faulty relief valve, just to mention a few. Oxygen concentrators have an inbuilt switch, an inbuilt thermal switch that will shut the compressor down if it becomes overheated to protect the compressor from damage caused by the overheating. So if this occurs, the compressor will only require a few minutes for the thermal switch to reset. If this is the case, it is best to find out where the overheating is occurring. It could be that there is a problem with the fan or wrong placement of the oxygen concentrator. So every compressor has a relief valve. A relief valve is a feature that is used to control or regulate the pressure in compressed air systems. It is used to prevent pressure buildup, which can lead to explosions and equipment failure. So as you can see in the graphics, the red arrow is showing you the relief valve on the compressor. So the relief valve achieves this by releasing excess pressure if there is pressure buildup in the compressor. For example, with the DeVille BIS 525, if the pressure goes above 45 psi, the relief valve opens and releases the excess pressure. However, if the relief valve is 40, it is possible that when there is pressure buildup, the relief valve is not going to open. This can cause the said vibrations and shutting down of the compressor. Sometimes this happens because the relief valve is stuck, so you can try to pull out the top disc of the relief valve using a screwdriver and check if it will start functioning. And if it doesn't, you can replace it with a new one. If the new valve works and it is popping, the next step is to figure out what is causing the pressure buildup in the compressor, and you should solve that problem. So this could be caused by, as I've already said, faulty rotary valves or maybe blocked sieve beds. Thank you very much.
Thank you very much, Eunice, for that explanation. I hope that was clear, and I'm sure if you try out the solutions that Eunice has suggested, you should be able to get your machine up and running again. But if you fail, you can always reach out to us, and then we can see what are the solutions we can suggest for you. If we have any questions or comments from the audience and the other technicians, we are free to add those comments. Okay, seems we don't have any questions there. So we have a poll at the end of this question, and I am going to ask Linda to launch that poll.
Thank you, Maui. So our first poll reads, have you ever encountered an overheating compressor? So I've launched the poll, and Maui, could you please explain to the audience how they can access the poll? Thank you.
Yes, so if you are joining us using your mobile phone, then if you click on the menus option on the bottom right of your screen, it will open up a window which has multiple options, and the activities button is one of those listed options. So if you click on the activities button, another window will open up, and from there you will be able to find the pause menu. So if you just click on pause, you'll be able to view the poll. And if you're joining us from your computer, then you also go to the bottom right of your screen, the icon on the far right, that's the activities button. So if you click on that, it will open up a window, and that's where the pause menu is also listed. Thank you, Linda.
Thank you, Maui. So it seems our votes are in, and most of us have encountered this problem. So it is a common problem. So I guess the solution that Eunice has suggested to us, it will help us whenever we encounter this problem. I'll end the poll now. Back to you, Maui. Thank you.
Thank you very much, Linda. So we are now going to jump on to our next question, which reads, the rotary valve on my DeVilbiss 515 concentrator is 40. Typically, I would expect the valve to rotate to a given degree, stop, rotate again, and stop while following a specific sequence. When I turned on the concentrator, the rotary valve rotates non-stop. How can I address this issue, and what might be the cause? So I'm going to ask Daphne to answer this one.
Thank you, Maui. So, oxygen concentrators have valves that act as a gate for the air in the oxygen concentrator. When room air is put into the concentrator and compressed by the compressor, it is directed to the sieve beds by these valves. And the valves are responsible for feeding air into the sieve beds, exhausting nitrogen from the sieve beds, and equalization. Different oxygen concentrator models use different types of valves to achieve this, and these valves include solenoid valves and rotary valves. The valves have different principles of operation, but essentially they have the same function. The DeVilbiss 515 oxygen concentrators use rotary valves to direct the air in the concentrator. The main parts of the rotary valve include a stepper motor, a horrific sensor, a magnet, a wire harness, and two rotating discs. So these valves operate using signals from the control board. The control board supplies the voltage to the valve, then it is quickly cycled to relieve residual pressure. This pressure is exhausted through an exhaust muffler that is connected to the valve. After this, the valve then begins its normal cycle. For this to happen, the valve must stop rotating once the magnet arrives at the horrific sensor. This location is known as home. The horrific sensor senses the magnet and sends a signal to the board, which stops the motor from rotating for approximately a second. After this, a short DC voltage is applied to the valve and it rotates 90 degrees. It then stops for several seconds, allowing the right bed to pressurize while the left bed is depressurized. Voltage is applied to the motor again, allowing the disc to move another 90 degrees until it stops. It then stops approximately a second, allowing the seat bed pressures to equalize. It rotates another 90 degrees and stops for several seconds, causing the left bed to pressurize while the right bed is depressurized. It then rotates another 90 degrees and stops for approximately a second for equalization. After these four 90-degree rotations, the valve has completed a 360-degree rotation and the magnet is back at home. Then the cycle repeats itself. From this explanation, we can see that even if the valve is rotating, for it to complete its cycles and occasionally stop to direct air, it needs a functioning Heusick sensor and magnet. So the cause of your problem might be a faulty Heusick sensor, demagnetized magnet, or a problem with the wires connected to the Heusick sensor. You can test this by unscrewing the sensor from the radar valve and using an external magnet that you are sure is okay. If the magnet is placed on the sensor and the valve does not stop, this means the magnet is fine, but the Heusick sensor or harness is faulty. You can check the integrity of the harness by conducting a continuity test on each wire. If the wire harness is okay, then you should replace the sensor. When replacing the Heusick sensor, please pay attention to the direction it is placed. Make sure that the black sub faces the magnet because it is used to sense the magnet. If the direction is reversed, the Heusick sensor won't be able to detect the magnet and the problem may persist. Thank you.
Thank you very much, Daphne, for that answer. I'm sure the explanation she has given is clear enough. And if you try out what she has suggested, you should be able to get your concentrator up and running again. But if you face any issues, again, we always encourage you to reach back to us and we will suggest more solutions for you to try out. So we have another poll or pause at the end of this question. So I am going to ask Linda to launch those polls.
Thank you once again, Maui. For this question, you have two polls. The first poll reads, have you ever come across a rotary valve that would rotate non-stop? So I'll leave it open for the audience to vote. So our votes are in, and it seems also this is a common problem that we face. And the second poll for this question is, have you ever come across a rotary valve with a faulty Hall effect sensor? So I'll also leave the poll open for the audience to vote. So the results are in, and it shows that it's 50-50. And for those of us that we have not yet faced this problem, I think the solution that Daphne has given us will be able to help you. So I'll end the poll now. Back to you, Mau.
Thank you very much, Linda, for that poll. Yeah, indeed, if we just try that out, I'm sure it's going to work out for you. So at least now you know how to deal with the problem when it happens. So now move on to our next question, which reads, hi, I'm a biomedical technician working at a certain district hospital. We have a DeVilbiss 525 unit that is producing low purity. Upon troubleshooting, I found that the rotary valve had some water droplets in it. Further troubleshooting led to the realization that there were some leakages on both sides of the sieve beds at the point opposite where the tube that goes to the accumulator tank gets connected. I'm not sure if this end is supposed to be closed or open, though, as I have never really taken note of what the normal setup is like. Can this leakage be the cause of the drop in purity? If so, how do I close up the end to deal with the leakage? So I'm going to ask Naomi to answer this one.
Thank you very much. First of all, there's a need to understand that oxygen concentrators work under the principle of pressure swing absorption, that requires air to be circulated in the unit at different pressures to get the required oxygen concentration at the outlet. The operating pressures of oxygen concentrators include the relief valve pressure, the sieve bed pressures, product tank pressure, and equalization pressure, just to mention a few. There was a call that we once did some weeks back, that was on 3rd November 2022, that talked about the pressures, the operating pressures of oxygen concentrators. So if you'd like more details on this, the link will be pasted in the chat and you can follow through the call. Different manufacturers of oxygen concentrators incorporate different ways of testing or checking the different operating pressures associated with the operation of the units. So for the DeVilbiss 525 model, it has pressure test points on the sieve beds and the product tank that are used for checking the pressures. So these test points are covered with an end cap that is placed at the opening of the test point. So when you're checking the pressures of the sieve bed and the product tank, the end cap tubing is removed and the pressure test assembly is connected to the fitting. After the test is done, the end cap is supposed to be replaced for optimum performance of the unit. So if the cap of the tubing is not replaced, there are going to be some leakages on the sieve bed or the product tank that can cause the unit to be registering low purity. Leaving this point open will also expose the zeolite to the humid environment, and water can accumulate in the sieve beds. That will also affect the capacity of the zeolite to absorb the nitrogen. So this water can in turn move to the rotary valve when the unit is running. If the rotary valve is working all right and it's only the water droplets that are causing an issue, you can remove the rotary valve and just dry out the water droplets. You also need to refill the sieve beds because there's a high chance that the zeolite has been affected by the exposure to room air. Also make sure that the end caps are replaced on the sieve beds and the product tank. So in the graphics, we can see the end cap. The arrows are pointing at the end caps of the product tank, but also the sieve bed in the DeVilbiss. Thank you very much, and back to you, Maui.
Thank you very much, Naomi, for that explanation. I'm sure the answer that she has given us is going to help us to solve the problem we're facing. And if you face any further problems relating to that, you can always reach back to us, and then we'll do our best to respond to you. Just a reminder for those of you that are joining us for the first time and you haven't shared with us your contact details yet, you can do so in the chat so that we can add you to our mailing list. And this will help us to send you updates and reminders of the next Concentrator Talk call and any activities that go on around in the Oxygen Alliance. All right, so if we have any questions or comments on the explanation that Naomi has given us, we are welcome to make those comments. All right, seems we don't have any comments there. So we'll now be moving on to our next question, which reads, hello, I am working on an AirSafe Elite. I am getting low pressure at the patient outlet. I decided to check for leakages and found that my product tank is leaking, and unfortunately we do not have any spares. I was wondering if I could use the oxygen concentrator without a product tank. So I'm going to ask Paulina to respond to this one.
Thank you, Maui, for the question. An oxygen concentrator begins its concentration process by forcing air into the device using a compressor. This compressed air travels to the solenoid or rotary valves, which are responsible for feeding the compressed air into the sieve beds, wasting air from the sieve beds, and equalization between the sieve beds. The sieve beds contain a molecular sieve material that absorbs nitrogen, leaving oxygen and a small percentage of other gases found in room air. The oxygen-enriched air is then accumulated in the product tank and then delivered to the flow meter through a pressure regulator responsible for reducing the pressure to a level suitable for delivery to the patient. And then it passes through a bacteria filter to remove any bacteria which may be in the air. The air is finally delivered to the patient after setting the flow on the flow meter according to the doctor's prescription. As we can see from this process, the product tank accumulates oxygen-enriched air from the 2 sieve beds. Each sieve bed may produce air of different oxygen purity. The product tank allows the oxygen from both sieve beds to mix, providing a steady oxygen purity to the patient. So if there were no product tank, the purity at the patient outlet would be affected. Additionally, it functions as a buffer to stabilize any pressure differences between the sieve beds. Some oxygen concentrators, such as the SF Elite, have zeolite in the product tank, as we learned from the oxygen talk last week. This helps to stabilize oxygen purity from the 2 sieve beds before it is delivered to the patient. As you can see, using a concentrator without a product tank can affect the purity, the flow, and the outlet pressure. So it is not advisable to use the concentrator without one. If it is possible, seal the source of leakage using epoxy. You can also scavenge a product tank from an oxygen concentrator of the same model that is not being used, or order another product tank for replacement. Thank you, Mavi.
Thank you very much, Paulina, for that response. If we have any questions or comments, we can make those comments. And if we have any questions, we can either paste it in the chat or just come off mute and ask your question. And the oxygen talk that she was referring to is also on our YouTube channel. So if you missed it, you can always catch up from our YouTube channel. So please, if you want to hear what was being presented by the AirSafe team, you can always refer back to that video. So we have another poll at the end of this question, and I'm going to ask Linda to launch that one.
Thank you, Maui. The poll reads, have you ever come across a leaking product tank? So I'll leave it open for the audience to vote. The votes are in, and again, it's a common problem. Most of us have ever experienced this problem. So let's remember, whenever we are replacing a product tank, we replace the product tank with one of the same model of the concentrator. So I'll end the poll. Back to you, Maui.
Thank you very much, Linda, for the poll. So we'll now move on to our next question, which reads, hello, I am a biomedical technician at Nsanje District Hospital. We have a Longfian J5 concentrator brought to our workshop. This concentrator doesn't turn on when plugged in, and the switch moved to the on position. What steps should I follow to troubleshoot and fix this concentrator? So I am going to ask Eunice to respond to this one.
Thank you very much, Maui. So there are a lot of things that can result in an oxygen concentrator not turning on when plugged into an power outlet. So the first thing you have to do is to check that there is no low voltage in your power supply. The J5 oxygen concentrator power requirement is 230 volts at a frequency of 50 hertz, although it works with voltages between 200 volts and 240 volts. So the J5 oxygen concentrator does not turn on when the voltage from the outlet is below 200 volts. Therefore, you need to check that the voltage coming from your outlet you need to check the voltage coming from your outlet using a multimeter if it's actually the voltage that you need. So low voltages and other power quality issues were looked into in more detail in the topic of interest that was done on 30th of October, 2022. So you can watch it on our Oxygen Alliance YouTube channel via the link that will be pasted in the chat. If the power outlet is giving out normal voltage after you have measured using your multimeter, you need to check the top plug connected to the power cord of your concentrator. Loose connections and a blown fuse inside the top plug can cause current not to pass and your oxygen concentrator won't turn on. The steps to test if the fuse is blown or not will be explained shortly. So if your top plug is fine, you need to check the fuse that is in the J5 oxygen concentrator. J5 concentrator has a fuse which is located on the power cord socket on the back of the concentrator. The fuse is rated 250 volts AC and 7 amps and is there to protect the unit from high currents or any short circuits which may originate from your mains power supply. As you can see in the graphics, the arrow is pointing at where the fuse is located. So you can just use a screwdriver to pull it out. And the other picture is showing you the fuse. So you need to test this fuse to see if it is blown or not. You can test the fuse using continuity test. So set your multimeter to continuity mode and place the probes on the fuse end cap. You should hear a beeping sound from the multimeter if the fuse is working, otherwise the fuse is blown. If you find out that the fuse is blown, you should replace it with the same rating fuse. Fortunately, the J5 concentrator comes with a spare fuse that you can replace the blown fuse with. You can find the spare fuse just below the fuse that was operating in the same fuse enclosure. Your concentrator should turn on now that you have replaced the blown fuse. From the power socket, the power is directed to the transformer that is located on top of the compressor enclosure. The compressor and then to the power goes from the compressor and then goes to the control board. To check if the transformer is working, you need just to test the output voltage on the transformer. The transformer has 4 output wires. Of the 4 output wires, 2 are yellow in color and carry 15 volts AC rated at 0.2 amps, and the other pair is white in color and carries 15 volts AC. You need to confirm those output voltages from the transformer, otherwise the transformer is faulty and has to be replaced. A faulty power switch on the concentrator can also result in an oxygen concentrator not to turn on. You can try putting a non-working switch in place of that one, in place of the one that came with, to see if the switch was at fault. The other thing you need to check are electrical connections. You need to make sure that there are no loose electrical wire connections in the concentrator, because these are going to cause problems. Thank you very much, Maui.
Thank you very much, Eunice, for that explanation. I'm sure the response that she has given us is going to help you to solve your problem. And as I keep saying, you can always reach back to us if you have any issues with the solutions, and then we can suggest other things that you can try out. So if we have any questions or comments at the end of this question, we are free to ask. All right, it seems we don't have any questions there. So we'll now take a short diversion from our questions and we'll jump onto our topic of interest. And as I explained at the beginning, today we'll be doing the second part of troubleshooting and fixing common problems in oxygen concentrators. So Fatsani is going to take us through that. Over to you, Fatsani.
Thank you, Maui. So today we'll continue with the topic of interest from last week on troubleshooting common problems in oxygen concentrators. So last week, Eunice talked about low oxygen purity problems and how it can be fixed. And today we continue with the high pressure problem that is also commonly encountered in concentrators. So high pressures in oxygen concentrators can originate in areas like the adsorption section, which include components like the sieve beds, exhaust muffler, and the valve block. So pressure buildup in this section can lead to stressing of the concentrator components, which eventually leads to failure. High pressures can also originate from the patient outlet, especially when the pressure at the patient outlet is higher than the specified range. And this high pressure can affect the purity of oxygen from the concentrator. So at the adsorption section, in most concentrators, the high pressure can be diagnosed by a popping relief valve. So a relief valve is a type of safety valve that is used to bleed off excess pressure in the system. And this relief valve is designed to open at a specific pressure. More information on the relief valve and its pressures can be found in the topic of interest that was done on the 3rd of November 2022, and the link to that video on our channel will be pasted in the chat. So some concentrators like the J5 have a pressure sensor that is connected to the solenoid valve, and when there is a high pressure, an LED on the concentrator will light up, alerting the operator that the system is also under high pressure. Sometimes if you have a working alarm system, there will be an audible alarm accompanying this high pressure LED. So in the graphics there, you see the first picture, you see pressure sensor that is on the control board of the Longian J5, and then the right picture is pointed at the high pressure LED that is found in front of the concentrator alongside other status lights. So now let's look at the causes of high pressure buildup in the oxygen concentrators. So starting in the compressor section. In the compressor section, can have a malfunctioning solenoid valve or rotary valve as one of the causes of high pressure buildup. So the function of the valve is to deliver air to and from the sieve beds at predetermined intervals. So this air is coming from the compressor, and then the valve open or close, allowing this air to move to the sieve beds or nitrogen to move out of the sieve beds during purging. So if the valve develops a defect, or if the valve is faulty, it causes a blockage that results in accumulation of air, and this will lead to high pressure. So you can check out if the solenoid valve is faulty by checking the resistors of each coil on the valve. The resistors have to be within the specified ranges by the manufacturer. So these resistors ranges can be found in the service manual that came with your concentrator. If you see that the resistors are okay, you can check if the valve is receiving proper voltages from the board. Sometimes it could be the board that is at fault, and also in some cases, the debris may accumulate in the valve, which may restrict the movement of air between the valve and the sieve bed. So this usually happens when you have dirty filters. You can have the cabinet filters or the gross particle filters. Maybe they are dirty, and the intake filter is also filled with dirty. So data may go through the system and block the valves. This may stop proper movement of air between the valve and the sieve bed. So you need to clean this if you see that there is accumulation of debris in the valve. To check if the rotary valve is faulty, you can check the voltages on the circuit board and make sure that they correspond to the service manual or the concentrator. You can also check the wire harness to the rotary valve. So this is done by testing continuity for each and every wire. If a wire is okay, you hear a beeping sound from the multimeter. If not, then the wire is bad. If the valve is found to be faulty, you can just replace it. Now, another cause of high pressure buildup in oxygen concentrators is blockage of the exhaust muffler or sieve beds. So the blockages will lead to air buildup and also high pressure. If you find that the exhaust muffler is blocked, you just need to replace it. And inside the sieve beds, the zeolite may also lump up. So in this case, you have to refill the sieve beds. And sometimes this high pressure can also be generated by the sieve beds. And when the sieve beds become contaminated with moisture, the zeolite loses its ability to trap nitrogen. And during the feeding process of the sieve bed, nitrogen molecules also pass through the sieve beds, and this may increase the pressure in your system. To check the sieve bed pressure, you can just disconnect the pipes from the sieve beds that lead to the product tank and then connect the pressure gauge. You need to check the pressure values to ensure that they are within acceptable ranges, which for most concentrators is between 25 psi to 30 psi. And any value greater than 30 psi is considered to be high pressure. Now, additionally, high pressure can result from installing an incorrect compressor in a concentrator. So the output pressures of various compressors differs. So this is dependent on a number of variables that include the piston cap condition, stroke size, and also bore of the compressor. And one of our topic of interest that was done on 3rd of November 22, we discussed more about compressor output pressures. So you can find this video on our YouTube channels, Oxygen Alliance. Now, at the patient outlet, different models of oxygen concentrators have different high pressure ranges. So in the graphics, you can see that across different models of concentrators, the pressures also differs. For example, the air-safe 10 liters or 8 liters, high pressure in the system is said to be greater than 20 psi, and for the air-safe 5 liters, we say there's high pressure in the system, the pressure is greater than 8 psi. For the Devil Beast 5.5 and 525 series, we say there's a high pressure in the system when the pressure goes beyond 8 psi. And for the J5, the Longifian J5, we say there's high pressure in the system when the pressure goes beyond 10 psi. So if you find that the pressure at the outlet is greater than the specified range, you can just adjust the pressure regulator to the desired range. So in some cases, if the pressure regulator is 40, that is the threads inside have become loose, the regulator may open or close during operation, and this may cause the pressure to vary. So if you find out the pressure regulator is at fault, you just have to replace it. And now let's look at the low pressure in oxygen concentrators. This is also a common problem that is encountered with oxygen concentrators. So this low pressure can originate from a number of places. For example, it could be the compressor service kits that are worn out, and this may require servicing. Or if there's a leak in the system somewhere, it could be a fault with the valves or a faulty pressure regulator, as I've already pointed out. So some of the factors that can lead to low pressure buildup in the system include: one, low output pressure from the compressor. So when the compressor has run for a lot of time without being serviced, the sleeves and the caps in the compressor can wear out, and this reduces the ability of the compressor to compress the air. And also when the relief valve for the compressor is faulty in a way that it keeps opening below specified relief pressure, the pressure output from the compressor is reduced. So for example, if you have a relief valve that is supposed to pop at 45 psi and you find that the relief valve is popping at, say, 30 psi, that can lead to a low pressure buildup in the system, because much of the pressure will be lost through the relief valve. So if you counter this problem, you have to replace the relief valve with a working one. And to find out the compressor's output pressure, you can just do this by connecting a pressure gauge to the exhaust port of the compressor, and then you compare the result with the specified output pressure from the compressor service manual. So in a service manual, there's always that specification of the compressor output pressure. So if you compare that gauge pressure that you're getting from the exhaust port and that in the compressor, for a working compressor, these pressures should match. If you find that there's a significant difference, then this compressor needs to be either serviced or anything that you might think of. So the other factor that can lead to low pressure in the system of oxygen concentrators is leakages. So a leak in the unit it allows the system pressure to escape, which can lead to low output pressure. So you can check for leakages in the concentrators by using soapy water. you just apply soapy water to the joints or anywhere that you suspect that there may be a leakage. And if you apply that soapy water, bubbles will appear whenever there is a leakage. So if you see that bubbles appearing, then it means there is a leakage and you have to fix that leakage. You can do this either if the leakage is on the fittings, you can just apply more thread tape, or if it's on the one of the hoses or the concentrator, you can just use hose clips or cable ties to tighten the joints. The other factor that can lead to low pressure in the system is faulty control valves. So a faulty control valve for a valve block, that is, say, a rotary valve or sonnet valves, if these valves are at faulty, they can also cause low output pressure. So this problem comes when the valves are failing to switch between feeding or wasting. And this can lead to the cycling happening in one bed, which results in different pressures in the sieve beds. If you are dealing with a rotary valve, one common problem is when it keeps rotating due to faulty Hall effect sensor, and then this can lead to low output pressure. So if you have a rotary valve that keeps on rotating instead of just rotating and stopping at some point, but just keeps on rotating, you can just go back to the solution that Daphne already explained so that you can fix this problem. And lastly, we're going to look at the pressure regulator. So low pressure at the patient outlet can result from a faulty pressure regulator. So in most concentrators, the pressure regulator is mounted on the product tank, and it controls the pressure flowing outside, flowing from the product tank to the patient outlet in the oxygen concentrator. So if this regulator is damaged or wrongly set, the output pressure can be reduced. And if you find out that the regulator is faulty, you have to replace it. If it's okay, but then the pressure is not matching with the pressure that is specified in service manual, then you just have to adjust the pressure regulator. So in the graphic there, you see a pressure regulator that is connected to the product tank in a double base oxygen concentrator. So reaching this far, that was all I had for you for in this topic of interest. A continuation of this will be in the next call. That will be next week. So over to you, Maui.
Thank you, Fatsani. Sorry, I had trouble finding my unmute button there. All right, so if we have any questions or comments for Fatsani, we can always ask those questions, or you can just paste them in the chat, and then he will respond to any questions that we have. Right, it seems we don't have any comments there. So we are still continuing. There is still more content that we need to share on troubleshooting and fixing common problems in oxygen concentrators. So please be available for our next course, and we'll pick it up from there. All right, so we'll now jump back to our questions. And our next question says, hello, I am a nurse at Mchinji District Hospital. I have been advised by the technicians to be washing the filters every week, but I also know that water can damage the concentrators, so we need to keep concentrators away from water sources. Is it really necessary to wash the filters? So I'm going to ask Naomi to respond to this one.
Thank you once again, Mari. So to answer your question, I'll first of all talk about what filters are, the types of filters that are found in oxygen concentrators, and their use. So the air that we breathe contains many particles that are microns or submicron ranges, though not visible to our eyes. Oxygen concentrators work by drawing this air into the machine and filtering out nitrogen and other constituents to have concentrated oxygen. The particles found in the air, if taken into the system, will clog concentrator parts, which can damage the machine and reduce its lifespan. Therefore, filters are used in the oxygen concentrators to trap these particles and prevent them from proceeding into the system. The concentrator uses 3 types of filters at different stages. The first one is the gross particle filter, the intake filter, and the bacteria filter. So the gross particle filter is like the first line of defense for the oxygen concentrator against dust particles found in the air. It traps the particles that are found in the air, the larger particles that are found in the air. So its appearance is more like a sponge or mesh screen that is usually found on the back of the concentrator housing or in the sides. So most of the gross particle filters are washable and they need to be washed with soapy water and air dried and then replaced back in its place. So from the graphics, we see on the left side the gross particle filter that is washable. The other particle filter is the intake filter. This one is connected to the intake of the compressor and it traps dust particles that may proceed through the gross particle filter. So the intake filter differs across manufacturers of oxygen concentrators. Some concentrators like the ASEP and the J5 have washable intake filters which can be washed, and some of them are not washable. So on the right in the graphics, that's a washable intake filter in the ASEP model. And the Devilbis 525 has an unwashable high efficiency particulate air filter that's abbreviated as the HEPA filters, in which you just replace them when you see that they are visibly dirty. So in the graphics on the left side, that's the HEPA filter that is not washable. You just replace it when it's visibly dirty. So the other filter is the bacteria filter, and this one is found mostly close to the product tank, where it is used to filter out or trap the bacteria that might have gone through the air to prevent and protect the patients from infections. So the bacteria filter looks more like a check valve, but just bigger. So on the right, we have the bacteria filter that is found in our oxygen concentrators. So a blocked bacteria filter does not allow air to pass and has to be replaced as it is not washable. Therefore, these filters that have been explained to be washable need to be washed weekly, because if they're not washed and they're clogged with dirt, they will obstruct the unit from working as it's supposed to be working, because the air will not be passing through it properly. So it will also affect the performance of the concentrator. Those that are not washable are just supposed to be replaced. So make sure you note which ones are washable and the ones that are not washable so that you can take very good care of them. Thank you very much, and back to you, Mari.
Thank you very much, Naomi, for that response. I'm sure if you try out the solutions that Naomi has presented, you should be able to get around your problem. If you face any challenges, you can always reach back to us through our email, and then we'll help you out with the next steps. If we have any questions or comments at the end of this question, we are welcome to make those comments. All right, it seems we don't have any questions there. So we have another poll at the end of this question. So I'm going to ask Linda to launch that poll.
All right, Maui, I'll launch the poll and it reads, have you ever watched an oxygen concentrator filter? So I'll leave it open for the audience to vote. So the results are in, and all of us have watched a concentrator oxygen filter before. So I'll end the poll. Back to you, Mau.
Thank you very much, Linda, for the poll. So we'll now be moving on to our next question, which reads, hello, I am a technician and I am working on an oxygen concentrator that was beeping a low oxygen alarm. My first guess was to check for leakages on the sieve bed connection and connections on the flow meter, and I found none. I then refilled the sieve beds with new zeolite, but the unit is still beeping the low oxygen alarm. I checked the concentration of oxygen being produced at the outlets with the oxygen analyzer and found the purity at 94.6. What can be the cause of the beeping low oxygen alarm and how can I fix it? So I'm going to ask Paulina to respond to this one.
Thank you, Mwawi. The primary use of oxygen concentrators is to produce high concentration of oxygen for oxygen therapy. Most oxygen concentrators have an oxygen sensor embedded in the unit. This sensor is used to monitor the concentration of the oxygen being produced by the concentrator. The alarm systems alerts the user if the concentrator has fallen, the concentrator oxygen has fallen below a certain threshold. There are several types of oxygen sensors that can be used for this purpose. Details on the oxygen sensors that can be used can be found in a topic of interest in one of our previous calls, which focused on the types of oxygen sensors, and the link for this topic of interest will be shared in the chat. It happens sometimes that the oxygen concentrator in the unit is faulty and is sending out wrong oxygen purity signals to the control board. Either it is sensing purity, high purity, when the purity is actually low, or it is sensing low purity when the purity is actually high. That is why there is a need to have an oxygen analyzer that can be used to test the purity of the oxygen being produced by an oxygen concentrator. So in your case, I would advise you to start checking the purity with an external oxygen analyzer as the first step in troubleshooting to avoid wasting other resources. For example, the zeolite that has been changed might have been producing high purity even though the unit was registering low purity. Secondly, you need to check if the tubes that connect to the oxygen sensor in the unit are properly connected. So the tubings that connect to the oxygen sensor are the ones that are green on the image on screen. If the tubes are connected properly and you are still getting an alarm, you can check if the sensor is faulty by replacing it with a spare oxygen sensor. So if the sensor is connected in a way that you can desolder or solder in a new one, if you don't have one on the shelf, you can scavenge from a dead oxygen concentrator and try to see if the sensor is really the problem. If you still get the beeping after changing the oxygen sensor, then the problem might be with the PC board. So there might be a fault on the PC board and you might need to change it to have a machine that is working accordingly. Thank you.
Thank you very much, Paulina, for that answer. I hope that was all detailed enough and we have our solution. If we have any questions or comments from the audience and the other technicians, we are free to make those comments. All right, it seems we do not have any questions. So looking at the time, it's almost 3, and this now brings us to the end of our call today. And I would like to thank each and every one of you for joining us for the call today. And hopefully we'll see you again in our next call. In case you happen to have missed any of our previous calls, you can always go on our YouTube channel where we post all the recordings of our previous calls. So please, if you missed any of our previous calls, you can always refer to that. We also had an oxygen talk last week, which was the final one of the year. And if you missed that one, you can also find it on our YouTube channel. We also have a website where we also post all these updates. So you can also go on our website and you'll find the links which are pointing to our YouTube channel from the website. And next week will be our final call of the year. So please make sure you are available for that call so that you also attend the last part of the topic of interest that we started in the previous call. So please make sure you join that call. And reaching this far, I would like to thank you all for joining us today, and hopefully we'll see you again in our next call. Have a great weekend and goodbye.